Thank you. I'm Dr. Arsalan Khushnood. I'm very thankful for this opportunity to speak at this prestigious forum. I'll continue the discussion which was previously discussed by Dr. Tariq, further adding on integrating sustainability into engineering curricula and the outcomes. I am working as the distinguished professor at Tunneling Institute of Pakistan, which is sixth of its kind facility in the world, and also I'm doing as the founder and CEO of Structex Consultants Private Limited, further promoting the sustainable engineering design solution in Pakistan and around the globe. A brief overview of my presentation, I'll briefly cover why we need sustainability add into the engineering programs, further the strategy which we can adopt for integrating sustainability, particularly from a curriculum design perspective, and further the academic challenges which are being faced usually in the smooth implementation of all sorts of device strategies, and how can we meet these challenges effectively. Further moving on to the mentoring of higher education institutes which can be done for effective implementation of sustainability strategies, further onto the future direction and Q&A. So the global challenges which we are facing include urbanization, like 54% of the population is urban population in the world. In Pakistan, we are also facing similar challenge, which is raising to 0.59% as per the World Bank data. There is an annual urban sprawl, and obviously that is counting for the pollution, congestion, and other social problems which we are facing right now. Also, there is a growth in population, which is 1.29% for Pakistan, as per the recent stat, as well as climate change is concerned, which is the major global challenge. Pakistan is fifth most vulnerable country as far as the hazards of climate change are concerned, as per the Global Risk Index, which is recently published. Further onto the water demand, prices, energy demand, which is getting high and high with the passage of time, food demand, biodiversity, and infectious diseases which we faced during COVID in the recent past. The only positive impact of COVID was related to climate, where we saw like reduced greenhouse gas emissions, which it resulted a bit in terms of better climate, which further enforces like by applying smart technologies in terms of transportation and industry, we can make our climate better for our future generation. So the perfect storm is we are adding in terms of energy demand, which is obviously higher as mentioned in 2030 target rules. It will be 50% high, 50% is increase is anticipated in terms of food. Also the water requirement for clean water is there. So we have to meet these challenges in which our engineering graduates have to play their critical role, because they are technically sound and they have to augment their technical skills with their social and environmental requirements in order to meet these challenges which we are facing right now. So sort of a mind diagram which I have drawn considering or emphasizing the need for sustainability in engineering education, which augments environmental impact which is associated with climate change and pollution, and also other impacts like economic benefit, social responsibility, education value, and regulatory compliance. So all these are parameters which are influencing, or you can say emphasizing, the need of sustainability towards engineering education. As far as International Engineering Alliance version 4.0 is concerned, which was released in 2021. So what they have done in knowledge and attitude profiles, there is an addition of WK9, which is purely emphasizing ethics, inclusive behavior and conduct, Further fostering knowledge of professional ethics, responsibility, and norms of engineering practices, awareness of the need for diversity and reason of ethnicity, gender, age, physical ability, etc., with mutual understanding and respect and of inclusive attitude. So, a particular emphasis has been given to WK9 by IEA in their recent version, followed with some revisions to WK7 and WK8, which are further fostering towards orienting our curriculum and engineering education on the targeted UN Sustainable Development Goals with their indicative global indicators, which have been compiled in their framework released in 2023. So WK8 is also fostering awareness of the power of critical thinking and creative approaches to evaluate emerging issues. Further, if we look into the graduate attributes and professional competencies, so there is a change as far as graduate attribute 6 is concerned, which is now changed from engineer and society and environmental and sustainability merger, and it is now called as engineer and the world, with further revision in the phrase analyze and evaluate sustainable development impacts to society, the economy, sustainability, health and safety, legal frameworks and environment, while solving complex engineering problems with its mapping to the knowledge and attitude profile 1, 5 and 7. Similarly, there is an addition of adaptation towards emerging technologies and critical thinking as far as PLO or graduate attribute profile 11 is concerned, which is lifelong learning. Further augmentation with professional competencies, which is a protection of society, legal, regulatory and cultural framework, which is the associated one with these graduate attributes. So fostering the need, or you can say considering the rationale of augmentation of these SDGs into engineering education. These are 17 SDGs which we all well aware of, as my colleague previously briefed in his presentation. So canonical representation of SDGs which we are fostering, like 5 P's principle: people, prosperity, peace, partnership and planet. What is the role of engineer in adopting these sustainable goals? So engineer has a very critical role because they are at the forefront of creating innovative technologies and systems that can minimize environmental impact and promote sustainability, because we can say it's a sort of three, sustainability is resting on 3 pillars, which is mostly dependent on environment, social protocols. So the engineers must have strength alongside technical prospects on the environment and social aspects as well to perform better in the society at large. So what could be the strategies through which we can integrate the SDGs into curriculum? So the first could be integrated approach to knowledge, attitude, skills and values in teaching, which is somehow practiced by the advent of project-based learning. Further incorporation of social sciences and humanities courses, which the engineering councils are already addressing by introducing the courses like sociology for engineers, civic and community engagement, occupational and public health relevant courses, which can be an add-on fostering, or you can say tilting, the orientation of our engineering graduates towards sustainability. Promoting in multidisciplinary teamwork by engaging our students into complex engineering group-based activities, which is also the requirement of IEA while implementing the outcome-based education framework to foster the flipped classroom approach as well while teaching. Simulate creativity and critical thinking, foster reflection and self-learning, raise awareness for challenges posed by globalization. Awareness, it can also be fostered through community engagement and a better industrial liaison which can be established. Mapping of SDGs with GAPCs, graduate attribute and professional competencies, and this mapping will augment an effective mapping, or you can say alignment of curriculum through GAPCs towards the relevant SDGs. a sort of, you can say, a tentative guide mapping, which is displayed in the slide for the attribute 6, engineer and the world, which is aligned to professional competency, protection of society, legal, regulatory, and cultural framework, followed with its mapping or association with knowledge and attitude profiles 157, and it can further be mapped with the relevant, or you can say selected, SDG, so that whatever we are expecting through curricula from an engineering graduate can further be translated into the sustainable development goal we are expecting from him or her during his or her professional life. This is how we can map a course content from the description, outcome, and the content perspective. Then it is further mapped with the activity through which that particular student may be assessed. You will see there is a mapping which is basically based on the key phrases, and it can be direct or indirect based on some sort of assigned scores using the global indicative framework of 2023. This is how they are further aligned with the graduate attribute and knowledge profiles. And again, their relation to the assessment framework, which can be a complex problem solving or complex engineering activity framework. So the other strategy could be by introducing courses which can be elective, or you can say foundation, breadth, or core level courses promoting sustainability, global warming and climate change, green technology and design, renewable energy, resource conservation, environmental history, occupational health and safety, sociology for engineers, civic and community engagement. So this is a list of courses, including the courses focusing digitization in engineering. In most of the cases, we see a boom of virtual reality, augmented reality, AI, building information modeling. So the three pillars which are augmenting these streams of courses are environment conservation, social equity, and environment growth. So all these parameters could be inculcated into our curriculum by designing of new elective or the foundation level courses. Followed with addition of topics, we can add some sort of topics into a course which augment the principles of sustainability, like life cycle analysis, design for environment, design for disassembly. And as listed in the slide, these prospects can be added to make our engineers well conservant while doing their job in the society. Further, teaching pedagogy is an important prospect which needs to be focused. Like, we have to focus on active participational and experiential based learning, and it can be promoted by introduction of case studies, project-based assignments, simulations and role-playing exercises, sort of flipped classroom approach, integration in terms of teaching, followed with partnership with our local organization or local industries to make our students well aware with the challenges which the industry is facing right now, through making our graduates interacting with communities through community service learning or other exercises. So all these pedagogies should be introduced or should be well focused to attain the targeted sustainable development goals. Further, while implementing these strategies, normally the academic challenges which are being faced is that engineering is a hardcore discipline, and its augmentation with the soft social sciences in curriculum design and especially in terms of delivery involves some sort of resource limitation and faculty training so that they can deliver that content effectively. So these challenges which can be worked on are there. In engineering education, obviously this transition would be a paradigm shift which will take certain time from diverting our engineers to have well conservance on all the three pillars of SDGs, covering their technical, social, environmental prospects. And in meeting these challenges or making this implementation effective, we need mentorship which can be done by accreditation councils at national levels. In Pakistan, Pakistan Engineering Council is doing a fine job. They have drafted a curricula guide for the engineering disciplines which are offered in Pakistan. 13 engineering program curriculum guide was published in the first phase. Nine has been recently published. Some other curriculum are underway to be published soon. So these curriculum guides, they are very effective. They are defining, or you can say guiding the institutes how the GAPCs they can be effectively mapped with the UN SDGs, and how the courses they can be aligned to the targeted SDGs framework through different activities which HAI can work on to further polish their graduate and align particularly their mission statements and the objectives according to what is expected at the globe in sustainability prospects, and also enforcing the need of emerging technologies, specifically AI and the virtual reality and augmented reality. Further, engineering councils, they are also working on development of codes. Pakistan Engineering Council is the recipient of Global Award 2023 because of the codes promoting sustainabilities which have been designed and published recently with the efforts of Pakistan Engineering Council. 4 codes have recently been developed in the last 3 years, specifically Green Building Code of Pakistan, Rainwater Harvesting Provision for Building Code of Pakistan. So all these codes which are augmenting the sustainability principles, they are further enforcing HAIs and other stakeholders to enforce or make their target to decarbonize the built environment in Pakistan as agreed in the Paris Agreement targeted for the year 2030. So ultimately we are moving towards our making engineers towards the future T, which is they should be strong in depth as well as in breadth in terms of business and people competencies. So engineering major or depth will be contributed towards the technology part, but the T shaped a well-conservant professional will be made by preparing him for all the breadth and depth domains, especially in social and environmental frame, as proposed by W. Murphy. And what will happen with the T graduates? Our graduates will be our asset to propose smart solutions or smarter solution for our planet. We will have smarter traffic system. You can imagine if we have electric public transport moving on the roads, we can expect a lot better in terms of pollution or greenhouse gas emissions contributed by the transportation industry in the recent time frame, followed with intelligent oil fields, agriculture, healthcare, each and every facility that can be affected by making our technology integration or engineering disciplines smarter. So it can be emphasized using the principle of making our T-shaped engineering graduates. And this is our future direction to have innovation by incorporation of emerging technologies and sustainability principles, further expanding interdisciplinary collaboration, and the long-term vision includes the continuous improvement and adaptation of curricula, promoting global collaboration and knowledge sharing through mutual exchange, which is also the purpose of this workshop as well. So that's all a brief from my side. Any questions are welcome. Thank you very much.